Hi friends, welcome to another section in this course, Convolution Neural Network. In this section, we are going to take a look at how to extract quality features from the dataset and how do we use max pooling to reduce image size, and then we'll take a look at increasing the accuracy with addition of dropout layers and also classification of data using the softmax function. And indeed, at the end, we will take a look at a sample code wherein we'll see image classification. In general, convolution neural networks are used for image classification. Data extraction. In this video, we are going to take a look at what is convolution neural network and how to extract quality features from dataset. Convolution neural network. In general, a convolution neural network looks like below. So these convolution layers are used to extract quality features of data from the dataset. So in general, what happens is if you are using an artificial neural network or something like that, then when you're going to pass an input, right, you will be passing lot of data to it, lot of information. For example, if you're having a picture here like 728 by 728 pixel, then what happens is your artificial neural network will have to process all the 728 by 728 pixel at a time. But if you're using a convolution neural network, you won't process this whole 728 by 728 pixel at a time, but rather you're going to process patches of these images at a time. So these patches of images, when you pass through this layers of convolution and max pooling, what you get is called as quality features. So we will take a look into it in the next slide of how these quality features are and what type of features we extract and so on. But in general, let's have an overview of our working of this convolution layer. See, in general, here you have an image, this image. So this is the patch which I was talking about. This patch will be sent through a layer of convolution, and then this convolution layer image size will be reduced using max pooling. And then once you get your quality data features here, this will be passed to an artificial neural network, and this working is similar to that as explained in the previous section of artificial neural network. And at the end, when you're having your data classified or something, you're going to use that final classification function as softmax. Why do we use the softmax? Because it increases accuracy. How does it increase accuracy? We'll take a look at it in the coming videos. So I believe now that you have a brief overview of convolution neural network, we should take a look into what is called as convolution. Convolution in general mathematics is nothing but multiplication of an input signal with an impulse signal to get an output. So just a refresher for you how this output is coming. So here you have this 1, right? This 1 at the 0th position will be multiplied with all the values of h, and then you are going to add this with the shifted signal of time by 1 position with all this again h values 2, 1, 1, 1, and then this will be summed up to get the final convolution. So this in way is what is general perception of convolution. But as I said, our convolution happens in the same way, but it happens in order to extract quality features of a dataset. By this quality features, what I mean is when you're passing our image, for example, say an image of a face, how this layers of convolution extract features is in the first layer you are going to get a single line, various types of single line. In the second layer it will be a combination of these two lines which is joined to form two lines. Then again it processes into a square, and then you have a combination of square. You can take a square as an example of an eye, means just a shape, not in fact to be. And as I said, as it goes through different layers of convolution, what all features you are going to extract, that will be fine-tuned. So combination of square, say like two eyes, or rather than square, you can take it as an oval shape if it feels comfortable to you. So then we are going to get this combination of squares and other shapes. And for example, like if you're having a face, right, you'll be having a face. So for face, you can say it's a rectangle or a square. And then for eyes, you can say oval shape. And for nose, you can say a shape of a triangle. And for lips, you can say it's something like an oval again or something different, whichever shape you prefer. So this is how you will have a combination of different features extracted. These features extracted will be passed to your artificial neural network, and the process is as similar to the one explained in the previous videos. So now let's look into a sample example of how, if you are passing an image with a filter, we are going to get the output. So as said, this H, right, filter, you can take it as an H in the previous slide, which is supposed to be an impulse signal. So for our input images, right, we are going to use the concept of convolution over patch sizes. So our patch sizes means we have a filter size of 3 cross 3. So this 3 cross 3 will be passed through our image like this, one step by step, and you're going to get the output. How do we use this, or how do we choose this filter size, and what is the reason for max pooling or image reduction? We look into it in the next video. So as you see here, this filter size, if you're going to multiply the filter with input, you're going to get an output as this. This will be your feature extracted quality feature. So is this case. You're going to multiply our input with this following filter, you're going to get something like this. If you do this on your own, say like with the help of a book and a pen, I'm pretty sure you will understand this data extraction really good, because this will define how you actually get the process of max pooling, and how is this signal layer convolution is happening here. So as a simple note, we have assumed a white to be a value of 2 and it is positive, and we have assumed a black to be represent negative with a value of -1. So this is regarding this, and I would highly suggest you to do this, because you doing this will help you get the clear understanding of convolution. And if you have like some sort of doubts or something, feel free to post me, and I will ensure that your two queries will be replied ASAP, because I want you to understand the concept first, because that is really helpful for your future in the field of deep learning.